Even the new ChatGPT gets this question wrong, just like 90% of people on Twitter did. At least I think so. Let's see if I can convince you. The question says, flip 100 coins labeled 1 through 100. Alice checks the coins in order, 1, 2, 3, and so on, while Bob checks the odd labeled coins, then the even labeled ones. So 1, 3, 5, and so on, up to 99, and then restarting 2, 4, 6, and so on. Who is more likely to see two heads first? If a child were doing homework and asked me this question, I would say equally likely. But that's not the case here. The Twitter account, Daniel Litt, is a math professor who asks tricky questions about Bayesian reasoning. So right off the bat, my intuition is that equally likely is too obvious an answer, and that can't be it. I'm betting the answer has to be Alice or Bob. Let's figure out the right answer first using this Python code to simulate the question. Then once we know the answer, we'll be able to reason about why. Over 1 million trials, I find that Bob wins about 40% of the time, compared to Alice winning just 30% of the time. That might surprise the child doing homework, but it fits with my prior expectation that Alice or Bob had to be the winner. This is a histogram of the number of coins that the winner had to check. And the key takeaway from this plot is that you never need more than 20 checks in order to establish a winner. That makes sense because it's just really, really unlikely that you won't see at least two heads if you check 20 coins. What that means for us is that most of the coin flips are irrelevant. The answer is somewhere within the first 20 coin flips. And also, we don't have to think about the behavior where Bob goes back to check the even number of coins, because that will never happen, or it will happen so rarely that it couldn't possibly explain a 10 percentage point difference. It will happen less than 1 in a million times. So we just need to think about Bob checking odd-numbered coins while Alice checks every coin. Here's a plot showing win percentage by number of flips, meaning instead of flipping 100 coins, what if we just flipped 2 coins, or 3 coins, or 10 coins? The value on X is the number of coins we flip, and the height on Y of the lines is the win percentage for Alice in red and Bob in blue. Two things to take away from this plot. One is that when the number of flips is small, less than 6, then the game seems balanced. Alice and Bob win a similar percentage of the time. As the number of flips grows up to 12, then Bob's advantage becomes clear. And at 12, Bob has the same advantage he does at 100 coins flipped, meaning Bob is winning about 40% of the time compared to Alice's 30%. What this tells us is that there's something different between the long and the short games. Long games means it takes 5, 6, 7 plus checks in order for the winner to win. That means Bob has checked coins number 1, 3, 5, 7, 9, 11, and so on. And that means that at most one of those coins that Bob checked could be heads. If more than one was heads, then Bob would have already won and we wouldn't be in a long game. And this is the difference. When Bob checks a coin, there's a 50-50 chance that the coin is heads and will contribute to Bob winning. By contrast, when Alice checks an odd-numbered coin, that's a coin that Bob has already checked. Bob has gotten there first, and we know by the fact that this is a long game that the odds of that odd-numbered coin being heads are low. If Bob has checked 6 coins, at most one of those 6 could be heads, so it's not a 50-50 chance that Alice will discover a head when she checks an odd-numbered coin. Instead, it's something like or a little less than a 1 in 6 chance. And Bob doesn't have any similar kind of disadvantage because Bob is always checking a new coin that no one has ever seen before, whereas Alice, every other coin she checks has been seen before. And the only time that this might balance out is if Bob reaches the end of the coins and goes back to check the even numbers. Now Bob would be checking coins that Alice has already checked. But we just never get to that situation because it's so unlikely for Bob to check 50 odd-numbered coins without seeing 2 heads. So I wrote this up as an essay and I showed it to ChatGPT to see if I convinced it. I did. Did I convince you? Thanks for your time.